Hello everyone. In this lecture I shall discuss the rectification, means the length of plane curves. Okay. So this is the consequence of your definite integral. If you recall the consequence of the definite integral or the applications of the definite integral, already we know the area bounded by the curves. Right. The area, what is the formula? The area is integral a to b y dx, the area bounded between the curve y is equal to fx and between the points of the ordinate, now point of the abscissa. Okay, and similarly it may be your integral some c to d x dy, or in between two curves it can be your integral a to b f2x minus f1x here dy, or it can be here integral some c to d, this is minus, okay, c to d, it is here f2y minus f1y dx, area in between two curves, right? This is area in between two curves, and this is area bounded by y is equal to fx and x-axis, area bounded by here x is equal to fy and y-axis, right? So already you have studied this thing, already you know this. Now in this current discussion we will study the rectification, okay, and subsequently we will learn the area of surface of revolution and the volume of surface of revolutions, right? Coming to the area of surface of revolutions, if we think of the surface of a cuboid, suppose you have a bricks, okay, it has it has six faces, right? Upper face, lower face, side face, front and back space, okay. So it will be twice the area will be given by, it is 2 times L into B, length into breadth, B into H plus H into L, right? Top and bottom face, side face, front and back space, in that way. And similarly the surface area of sphere, it is given by 4 pi r square, right? We will discuss later on, we will discuss. Similarly the volume of revolutions, if you recall the volume of a cuboid, it will be here length into breadth into height. Volume of a sphere 4 by 3 pi r square, it is 4 by 3 pi r cube, okay. So now rectification means now the process of finding the length, we can write it in that way, the process of finding the length. Now what is the rectification? The process of finding the length of an arc of a curve, right, between two given points is called rectifications, right? We will discuss in details. So now this thing already we know from school geometry mensuration, but here all this thing we will discuss as an applications of the definite integral, right, as an application of the definite integral. In this point of view we will learn here, right? So before the details of my discussion, let me to introduce myself, Professor Susanta Kumar Paikray, currently working as a Professor of Mathematics at Veer Surendra University of Technology, Burla, Sambalpur, Odisha, India. Okay, so before the details of my discussion, I have an appeal to all of you is that please like and subscribe to this lecture, which will boost my motivation to upload subsequent lectures for your benefits. So I have uploaded a series of lectures on engineering mathematics, so you can go to the playlist and see the lectures as per your requirements. And if you subscribe it, then the benefit is that whatever the new lecture will be uploaded, it will come to your screen, okay. So please like and subscribe to this channel, and at the same time you share it with your friends so that all of your friends will be benefited. So let me to discuss the details about the rectification in this lecture, followed by 2 more lectures on area and the volume of surface of revolutions, okay. Now coming to the rectification, you are given a curve C. This is a curve C, and we are asked to find the length of the curve in between A and B. Okay, this length we need to find, right? This length we need to find, right? So this is my rectification. So now to understand the formula of rectifications, let me to consider a plane curve. In xy plane we have a curve C. We have a curve C. Suppose this is my curve. Okay. We have two neighboring points on C. We have two neighboring points on C. Let this point be my A point and this point be my B point. So this is my, consider the curve C, two neighboring point P and Q. So this P and Q is my chord. Okay. Now I join, this is my arc. P and Q is my arc. Suppose I join a chord here. I join a chord PQ here, and this gap is my H, or I call it suppose my del S, right? Suppose this is a point, my A point here. So now this length is suppose my S, and this total length of from A to S, it is my suppose S plus del S. Okay, S plus del S. The moment my H tends to 0, right, this arc PQ is same thing as the chord PQ in length, right, in length. Okay, so from this concept we will derive the formula for the arc length. So now what is the coordinate of the point P? Suppose this is my x-axis and this is my y is equal to fx. So now this point is here, say x fx, say, and the coordinate, and this point you say suppose here x plus h, fx plus h you say, right, you say like this. Now the moment h tends to 0, right, now this will reduce to a single point. So this arc PQ will be same thing as the chord PQ, will be same thing as the chord PQ. Okay, this length and this length will same. Okay, so let us find the length of the individuals, right? So what is your length of arc PQ, and it can be viewed as your, this is S plus del S or S plus H. You say it is x plus h, and you say it is your x. Okay, you say it is your x. Now the moment here limit h tends to 0, right, the limit h tends to 0, if you divide one h here, so this will give you ds by dx, right, first principle formula. So now we will see the length of the arc. So this is in view of arc PQ, right, and in view of the length of the chord, this is your chord PQ, this is your chord PQ. So what is the length here? Distance formula, it is a distance formula, square root of here x plus h minus x whole square plus f of x plus h minus f of x whole square, x2 minus x1 square plus y2 minus y1 square, right. So this will be equal to here h square plus f of x plus h square minus this is this whole square root over, right. Now taking here h common, now if you take this h square outside the root over, it will here h, and it will square root of, it becomes here 1, it is here f of x plus h minus fx and divided by h whole square. Okay, is not it? Now in the same way, if I take limit h tends to 0 and I divide one h as I divided here, right, if I divide one h here, so this will be my limit h tends to 0, h into square root of 1 plus f of x plus h minus f of x by h whole square, and it is divided by my h. So now this my h and h cancelled. It will be my simply here 1 plus here dy by dx whole square, dy by dx whole square root over. Is not it? So what we see, so it can be estimated as 1 plus dy by dx whole square root over. Is not it? So you see, this when this p tends to q means this shrink to a point, this length of this arc is same thing as this length of the chord. Okay, we don't need these details of derivation, we just need the formula. Okay, how this formula is being generated. So what is my length of the arc? So what is my ds now? My ds will be here root over of 1 plus dy by dx whole square dx. Now what is my s? S is my integration of this. Okay, so this is my formula. So this s for the your arc length pq, right? I will get, this is my formula here. So I need only this formula. Okay, and if it is my point a point and it is my point b point, and accordingly I have a formula like this. So I am going to recall the formula only. This derivation is not necessary. Okay, we will just see the formula and accordingly apply it to solve the problems. Now we have the formula for the arc length. Okay, in Cartesian system, means suppose you are given a curve y is equal to fx, you are given, right? Means as we discussed above, we have a curve, suppose y is equal to fx, and we want to find the length of the arc in between a and b, right? And this is the point on the x-axis is my a and it is my b. Then this length of the arc, this is my l, length of the arc. Here l will be given by l, means here s in between a and b is 1 plus dy by dx whole square root over, this is integral a to b dx. This is the formula. Okay, if the curve is given as x is equal to fy, right, in between some say y is equal to c2, y is equal to d. Suppose my this is my curve, from c to d, right? In y axis it is in between c to, in between here say c to d. Okay, this is my c, this is my d. Then what is the formula here? And this is my p and this is my q. So this length of this arc, right, in between p and q will be integral c to d 1 plus dx by dy whole square root over dy. In that way we can apply the formula for the length of the arc. For this length of the arc here like this, and the length of the arc is this. Okay, so let us solve one example. So coming to your example 1, you are asked to find the perimeter of a circle x square plus y square is equal to a square. So actually this is my circle here, right? This is my circle here. The center is at origin and this radius is a. And we know what is the perimeter. It is 2 pi r. R is my a here. A is my radius, right? The perimeter is this. It is known from the school geometry. Now we will prove it. Okay. So now means this is the length of the curve. Means if I find this length because of this symmetry, it is 4 times this length. What is the coordinates of this point? This is a0. And what is the coordinate of this point? What is the coordinate of the points? It is here a0. We don't need it. What is the coordinate of this point? It is 0, 0. Right? If we want to find the length of the arc, means I find the length of this and I multiply 4, then I will get the result. Okay. So what is my y is equal to fx? My y will be root over of a square minus x square root over is my fx here. Y is equal to fx. So what is my length here? The length of the arc here is 4 times integral. It is the x, limit of x from 0 to a here. Integral 0 to a 1 plus dy by dx whole square root over dx. Similarly, in view of x is equal to fy, I can also think of. So this is equal to, we can write here, what is here y, here x square plus y square is equal to a square. If we differentiate with respect to x, it is 2x plus 2y dy by dx is equal to 0. A is constant, so what is your dy by dx is your minus x by y. So it is 4 times integral 0 to a, here 1 plus whole square of minus x by y means x square by y square root over here dx. If you solve it, so it is 4 times integral 0 to a y square plus x square root over, okay, it is divided by y dx. Now what is your y square plus x square is your a square, so the numerator becomes 0 to a, it is a dx, and the denominator y is root over of a square minus x square, okay, it is a square minus x square root over. So if you recall the integral formula, it will be 4a taken out, integral 0 to a, it is dx by a square minus x square root over. So what is the integral here? So it is 4a, it is sine inverse x by a, is not it? It is sine inverse x by a, limit from 0 to a. So now the upper limit minus lower limit, it is 4a sine inverse 1, sine inverse 1 minus sine inverse 0. So sine inverse 1 is here pi by 2, sine inverse 0 is here 0. So what I am getting? I am getting 2 and 2 cancelled here. So it is 2 pi a. Is not it? Is it not equivalent to here 2 pi r is a radius? So I am taking it here. Okay, so whatever we know from the school geometry, by application of this definite integral, we just prove it. Okay, so this is what the area, this is what the length of the arc or the circumference of this circle, center at 0 and radius a. So as you see the length of the arc under Cartesian system, we will consequently see the length of the arc for parametric system. Okay, suppose you have parametric system. Parametric system means your x is your xt and y is your yt. T is a parameter here. T is a parameter here. For example, if you have a circle, x square plus y square is equal to a square. If I put x is equal to a cos t and y is equal to a sin t, right? Then your x square plus y square, right? This implies your x square plus y square is equal to your a square. Sin square t plus cos square t is your 1. Okay. So now this is in which form? Cartesian form. But this is in parametric form. So for a complete rotation, so what is t here? T is the complete rotation here. So t ranges from 0 to 2 pi. It creates angle from 0 to 2 pi. 0 to 2 pi rotation will give you the parametric representation of the circle. Okay. So here we see in parametric system, what is the formula for your length of the arc? Now if your x is equal to y, x is my xt and y is my yt, and what is the length of the arc? Okay, length of the arc here in between t1 and to t2, say it is, say some t1 to t2. Okay, dx by dt square whole square plus dy by dt whole square root over dt. So this is the formula for length of the arc in your parametric system. Now coming to one more example, find the entire length of the curve x is equal to a cos t, y is equal to a sin t. You see, this question is same as the previous question. So the answer should be 2 pi a. Okay, and it is again the same circle, x square plus y square. If you add it, it is a square, sin square theta plus cos square theta is a square. So means this is the same circle itself. Okay, this is the same circle itself from 0 to 2 pi. If I consider the circle in the first quadrant, okay, and here the angle of rotation, so this is my pi by 2, okay, and it is my 0. Here the angle is my 0 here. So if I take 0 less than t less than pi by 2 in the first quadrant, then what is my length? My length will be 4 times, because of the symmetry, this plus this plus this plus this. So 4 times integral 0 to pi by 2 dx by dt whole square plus dy by dt whole square root over dt. Okay, or directly, if I do not multiply 4, the entire limit is 0 to 2 pi. Okay, it will be simply 0 to 2 pi dx by dt square plus dy by dt whole square root over dt. We may use either of these two formula. Okay, suppose if we work in this line, then it is my 4 times integral 0 to pi by 2, and it is what is here dx by dt. Dx by dt is here minus a sin t. Okay, minus a sin t square plus dy by dt here a cos t square dt. So this is here a square sin square t, right? It is here 4 root over dt. So it is here a square means a 0 to pi by 2 simply a square into 1 root over dt. So this is equal to 4 0 to pi by 2 simply a taken out, it is dt. So this is 4a t 0 to pi by 2. So this will be 4a pi by 2 minus 0. So this will be here 2a 2 pi a. Okay, 2 cancelled 2 pi a. So we are getting the same answer as in previous case. Okay, we are getting the same answer here because the same curve, it is represented in parametric form, right? Now if we move like this also, we will get the same answer, is not it? If we move in this way, what we are getting? We are getting 0 to 2 pi here a square dt. So a square root over dt. So a, it is t 0 to 2 pi. So this will be a 2 pi minus 0. So it is 2 pi a, right? So the first you imagine the figure in your mind. Okay, accordingly you can see the limit. Clear? Now let us solve few more examples, and in another two coordinate systems. One is the polar coordinate system, and again one more is the pedal coordinate system. As we see, one is your Cartesian system and another one is your parametric system, right? Two, and similarly two more systems we have. One is the polar system. In polar system, the curve is, it is given in r theta coordinate. Okay, it may be y is equal to, or your r is equal to f of theta, right? R is f of theta. So theta is the angle of rotation here, or it can be written as theta is equal to some f of r, right? Means in general it is in r theta system, right? So here what is the formula? The length of the arc here is given by integral some angle theta 1 to theta 2 here r square plus dr by d theta whole square root over d theta. So theta is the variable here, right? If we express it in this way, then what is the formula? The formula here will be, here L will be, here the r is the variable here, radius r1 to r2 here. Okay, so it will be 1 plus r square, one more thing, 1 plus r square, it is d theta by dr whole square root over dr. Okay, but usually we are acquainted with this, r is equal to f of theta, right? So function is r is equal to f of theta in polar form. Likewise we have here pedal form. In pedal form it is given in the form of p is equal to f of r, right? P is equal to f of r form. And what is the length of the arc here? So r is the variable factor here. It will be integral from r1 to r2. It is r by square root of r square minus p square. Okay, it is dr, right? So this is the length of the arc in the pedal form. So now in view of the consequence of your polar system, suppose we are going to use this formula. Suppose you are given you are asked to find the perimeter of the cardioid. What is the cardioid? R is equal to a into 1 plus cos theta. It is given, the cardioid is given, means it is of the form r is equal to f of theta. So we understand it is in r theta system, right? Similarly one formula for the cardioid is r is equal to a into 1 minus cos theta, right? It is given r is a into 1 plus cos theta. So actually we don't need the picture, but the picture of this cardioid is like this. Okay, the picture of the cardioid is like this. Okay, the picture of the cardioid is like this, right? This is your cardioid. Means if we find the area over this part, okay, the length over this part, then the next part, because of the symmetry, we just multiply 2. And what is the rotation here? It is from 0 to pi, right? The rotation here is 0 to pi, right? So here theta is from 0 to pi, and we are going to multiply 2 because of the symmetry. Okay, so what is the length of the arc here? L is my integral, twice integral 0 to pi. Okay, 0 to pi, it is here r square. What is the formula? R square plus dr by d theta whole square plus dr by d theta whole square root over d theta. Okay, so what is your r? So that is equal to, your r is twice integral 0 to pi, your square root of r square means a square 1 plus cos theta whole square. What is your dr by d theta? It is minus a sin theta whole square, means a square. It is your minus a sin theta whole square. Okay, it is minus a sin theta whole square. Okay, it is d theta. So if you evaluate it, so if you simplify it, just you open it, here 1 a square and here 1 a square, you can take this a square, means a outside, it is here 1 plus cos square theta plus 2 cos theta and plus it is here sin square theta plus cos square theta is here 1. So this root over d theta. So this is here 1. Okay, so what we are getting? 2a 0 to pi square root of, it is your 2 plus 2 cos theta d theta. So now this is 2a integral 0 to pi. Now square root of 2 taking common, it is 1 plus cos theta d theta. 1 plus cos theta is 2 cos square theta by 2. It is equal to 2a 0 to pi 2. This is your 2 cos square theta by 2. Okay, this root over is there. So this will be 2 taken out. It becomes here 4a. Only 2 will be here. So it is 0 to pi. It is cos theta by 2 d theta. So if you integrate it, it is 4a. Integration of cos theta by 2 is sin theta by 2 divided by 1 by 2, means this 2 will be multiplied again here 0 to pi. Okay, so this is 8a. It is your sin pi by 2 minus sin 0. Sin pi by 2 is 1. 8a into 1 is 8a. So we have again, suppose you are asked to find the perimeter of this, right? So this is again another cardioid. Okay, so equation of another cardioid, and here we don't need the curve, but the curve is like this. Okay, the curve is like this. And here similarly, if we think it is from 0 to pi and 2 times this length, right? So here this L will be 2 times integral 0 to pi, the same formula, r square plus dr by d theta whole square root over d theta. And if you evaluate it, we will get the same answer. Okay, so this is your answer here. It is same. Now in view of the pedal system, here p is equal to small p is equal to your f of r. We have, this is the formula. So let us solve one example in view of the pedal system. Find the length of the arc. P square is equal to where? Of course it is a parabola in pedal form, right? So we don't bother about this diagram. We have given the limit here, entire limit here, a to 2a, right? So what is the formula? The length of the arc here is integral a to 2a r dr divided by r square minus p square root over. Okay, if you simplify it, you can simplify it. So if you simplify it, it is here 0 to here a to 2a, right? R dr. So variable my r here. So it is my r square and p square is minus ar. Okay, this root over, and you just go on simplifying. Okay, go on simplifying, and the answer will be a square root of 2 plus log root 2 plus 1. So this will be your answer. Okay, actually this Cartesian system and the parametric system are much more important. So we will talk about more problems on parametric form and Cartesian form. Actually, you are given one more curve. Find the length of the entire curve. This. Actually, the name of the curve is asteroid. Okay, these are some standard curve. Okay, and what is the shape of the curve? The shape of the curve is like this. Right, the shape of the curve is like this. The shape of the curve is like this. It is here A0, it is 0A, it is minus A0, it is 0 minus A. Okay, and if you bring it into the parametric form, then if we put x is equal to a cos q theta, y is equal to a sin q theta, means you see x by a to the power 2 by 3 plus y by a to the power 2 by 3 is equal to here 1. Okay, so now if you substitute this, we will get the same result. So this is converted to the corresponding parametric form, right? Parametric form. So either we may work with this in Cartesian form or parametric form, it is same. However, it will be easy, right? So now is this theta. So here if we take this length over here, then it is my theta is equal to 0 to theta is equal to pi by 2. I multiply 4 here. Okay, so what is my formula here? So my length of the curve, my L is equal to my 4 times integral 0 to pi by 2. Okay, dx by d theta whole square plus dy by d theta whole square root over d theta. I may take theta or I may take theta or I may take t. This is immaterial. Okay, so now what is my dx by d theta? So this is 4 times integral 0 to pi by 2 dx by d theta is cos q theta, here 3a cos square theta into derivative of cos theta is minus sin theta, then dy by d theta is here this is the whole square of this dx by d theta whole square plus dy by d theta whole square. It is 3a sin square theta into derivative of sin theta is cos theta. Okay, this root over this whole square root over d theta. If we simplify it, okay, it is 3a whole square 9s a square. So it is 4 integral 0 to pi by 2. It is my 9s square, right? It is here cos 4th theta sin square theta, right, plus it is here sin 4th theta cos square theta square root d theta. If you simplify it, it is 4, it becomes here 3a 0 to pi by 2. If you take common cos square theta sin square theta, okay, then just sin theta cos theta will come out, then it will be square root of cos square theta plus sin square theta d theta. It is here 1. So now this will be, if I divide 2 here and multiply 2 here, it is 2 sin theta cos theta is sin 2 theta. So this is here 6a 0 to pi by 2. It is sin 2 theta. It is here 1 d theta. If you integrate it, it will 6a integration of sin 2 theta is minus cos 2 theta divided by 2, right? Integration from limit 0 to pi by 2. So this is my taking minus outside here. It is here 3a and it is cos pi minus cos 0. Cos pi is minus 1. So this is equal to minus 3a into minus 2. So this is 6a, right? This is 6a. Likewise, if you have one more question, you have in the similar line we have this curve. Okay, this is again asteroid, right? This means you put x is equal to a cos q theta, y is equal to b sin q theta, and here the asteroid here will be it will be like this, and it is here a 0 and it is here 0 b, it is 0 minus b, it is here minus b 0, in this way. And accordingly, if you apply the same formula, here L is equal to integral 0 to pi by 2 4 times, okay, dx by d theta whole square plus dy by d theta whole square root over d theta, and your answer will be, if you go and simplify, your answer will be 4 by b square minus s square. It is bq minus aq. So this will be equal to 4 times b square plus ab plus s square divided by b plus a. Okay, so this will be your answer. Let me to solve one more example. So coming to the concluding example, prove that the length of the arc of the parabola from the vertex to an extremity of the lattice rectum, okay, y square is equal to 4ax. So the parabola is symmetric about your x-axis because the power of y is even, right? So this is my parabola, right? The focus of the parabola is your a0. It is your a0, right? So now this is the lattice rectum here. The lattice rectum, the length of the lattice rectum is 4a, okay, and you are asked to find the length of the arc of the parabola from the vertex to an extremity. So this is one extremity, this is other, so this extremity. So since this length is 4a, it is your 2a, so it is your 2a0, okay. And you are asked, right, you are asked the length in between this and this. You are asked the length in between this and this, right? Arc in between this and this. What is the coordinate of this? It is 0 0, right? So the limit we can take from 0 to 2a in view of your x. Sorry, this coordinate will be a 2a, is not it? So this coordinate will be your a 2a because this is your a 2a, okay. So what is the length of the arc here? Here s is equal to integral, suppose in view of x1, in view of x1 to x2, 1 plus dy by dx whole square root over dx. Now in view of here y, it will be x1 to x2, y1 to y2, 1 plus dx by dy whole square root over dy. So here this y will be easy here because finding here y square is equal to 4ax, okay, in view of your dx by dy. So what is your x? X is 1 by 4a y square. Now what is your dx by dy? It will be 2y by 4a, okay. It is your y by 2a. So it will easy now. So in view of your y, right, it is here from a to, in view of y, it is from here 0 to 2a, okay. So this will be integral 0 to 2a 1 plus dx by dy square. So what is your dx by dy? It is your 1 plus y square by 4a square, right, dx by dy root over dy, okay. So this will be equal to 0 to 2a here 4a square y square plus 4a square root over, this is 1 by 2a taken out dy, right. So this will be 1 by 2a integral 0 to 2a y square plus 2a whole square dy. So at this juncture you can apply a formula, integration x square plus s square root over dx. What is the formula? X by 2 root over of s square plus x square plus x square by 2 ln x plus root over of x square plus s square. This is the formula. So you are going to apply this formula and simplify it. So in view of this, it is your s square. So this will be 1 by 2a integral 0 to 2a. Now after integration, it will be 1 by 2a. If we integrate it, x by 2 means my y by 2 square root of s square plus x square means 2a whole square plus y square plus s square by 2a means 2a whole square by 2 ln root over of your y plus x square plus 2a whole square, okay, ln this. Now ln this is root over of this is y, okay, y from the limit 0 to 2a, limit 0 to 2a, okay. Just you simplify it, substitute the limit, okay, and you will be getting a into root 2 plus log root 2 plus 1. Since the video is getting lengthy, I just skip it. Okay, so I should complete this integration by using this formula, right? So one set of lectures covers the entire rectifications, so you are required to go through some examples from any standard books. So now I should conclude this lecture here. So before I conclude, once more I appeal to all of you, please like and subscribe to this channel. It will boost my motivation to upload subsequent lectures for your benefits. Okay, in the subsequent lecture I will discuss the volume of revolution, the area of revolutions. Okay, so let us conclude, and thank you all. Have a nice day.